Okay, welcome. I can see that. Okay. I don't think my microphone is working, right? It seems to be, but okay, now I can see the microphone working. Great. Just going to turn the sound up a little bit. There we go. Okay, good. All right, so this is lesson. I gave you time yesterday to work on lesson 1, which is characteristics of quadratic functions. And I thought today I would finish through going through a couple of the questions from assignment 1, right? I'm not going to start the new topic. I'll start the new topic Monday, applications. This is a quicker unit, as you can see, because most of the really important concepts we already learned with the linear functions. I'm just going to move over, and I hope I don't screw up the focus. Okay, try focus again. All right, so what we're doing is you were supposed to analyze each quadratic function by sketching if required. The first one was sketched for us. Now, the interesting thing is, if you know what the vocabulary words mean, you can answer a lot of these, or you can respond to a lot of the questions that they ask you just by inspecting the graph. So in this case, the graph is given to us, or I should say by inspecting the equation. For number 1, they do not give us the equation, they give us a picture, but I can tell by looking at the picture that it's a quadratic. So it's a quadratic function. It's an upward shaped quadratic function. That already tells me a lot that I need to know about this quadratic function. The quadratic function, the opening is up, right? You can say up or upwards. That means the sign of the leading coefficient is positive. The end behavior, this is quadrant 2, and this is quadrant 1. So we say from quadrant 2 to quadrant 1. And the y-intercept, well, let's see, that's where the graph crosses the y-axis, and this is a nice clean crossing. So that would be at -3. The x-intercepts are where the function crosses the x-axis. So that would be -1 and 3. Now, I don't need any special technology for this question because the graph is nicely displayed for me and it's easy to read. We'll see, though, as we proceed through this assignment, when we do a couple of more questions, the pictures aren't given to me, right? So I have to draw the picture myself and provide the requested info. The vertex is the turning point. It's kind of the halfway point. It's a very important point of the quadratic. It's probably even more important than the x or y intercept. So as my pencil draws the quadratic, you see I'm moving downward. I stop here and then I start to move upward. Where my pencil takes that turn, right, from going down, your quadratic has one or the other. The domain of every quadratic is just x is an element of the real numbers, meaning x can be any real number, right? This quadratic, this parabola is made up of millions and millions, trillions of points, an infinite number of points. It's the collection of points that creates this illusion of a straight line, but this line is actually made up of millions of points, and each coordinate point has an x and a y value. XER means x really can be any number in the number system, right? All the way from negative to positive infinity, because the graph grows forever and ever and ever sideways, right? So the graph grows forever and ever to the left and the right, and it grows forever upwards, but it doesn't grow forever downwards. The domain then is restricted, and we say y can be any number, but it's any number greater than or equal to -4. Okay, so that's how we display this. Let's try number 2. So number 2 is a little bit different because it does not give us the picture, it gives us the equation. So that requires a little more work on our part. So I pick up my calculator and I make sure that the calculator is cleared out from any previous info, so that when I enter my y equals statement in, I'm entering it into a brand new, clean, fresh calculator. So 3, just going to move this up a little bit. 3x squared, x, subtract 13. We're going to press graph. And I do see a graph, like I trick with zoom 0, but I avoid using zoom 0 unless I absolutely change the y min to, I don't know, how about negative, I'm going to go big, negative 50. Okay, that might have been too much. I'm going to take it back a notch. Let's try negative 30. That's a little nicer. My graph is a little more centered. All right, as long as you can see your x-intercepts, your y-intercept, and your vertex, right? And I should say I'm only concerned about x-intercepts if there are some, because we know that there are some quadratics with no x-intercepts. So if there are x-intercepts, I want to see them, the y-intercept and the vertex. Okay, so this graph is an upwards graph, so positive lead coefficient. And you probably picked that up from just looking at the statement, because the a value is positive. It's given to me in the correct form, right? The ax squared plus bx plus c. So as long as it's given to me in this form, 1, 2, 3, an x squared term, an x term, and a constant, I can look at the lead coefficient and it'll tell me that it's an opening up and the lead coefficient is positive. If the lead coefficient is positive, you know it's a quadrant 2 to quadrant 1. I don't know the x and the y-intercepts or the vertex or the max or the min. I do know the domain though, XER, right? All right, now I'm going to draw this graph. Now, a couple is, because you're just being asked to sketch, it doesn't have to be anything super fancy. I'm just going to kind of duplicate what I see here. I see an x-intercept about here and here, y-intercept here, and my vertex is here. I might move my y-intercept over a little bit, or this x-intercept over. So I'm just going to connect those little kind of like that, right? The graph's a little wonky right here. I'm going to try and clean that up a bit. Okay, so there's my quadratic. Now I actually have to identify the coordinates of my x-intercepts, my y-intercept, and my vertex. It doesn't really matter which we approach first. Let's do the easy one first, the y-intercept. Okay, remember that procedure? Second trace value, x is 0. So y is negative 13. Now let's try the x-intercepts. That's our same procedure we used. We put a y2 statement in. y2 is 0. And then I go second trace and I choose number 5. And I answer my 3 questions, right? But I'm trying to find my x-intercepts, this one and this one. It doesn't matter which one you do first. So let's move over here. I have to move my cursor over. I answer the 3 questions, yes, yes, yes. And when I say yes, I'm just pressing enter, right? Yes, yes, yes. And when you get the word intersection, you know you found your x-intercept. So this would be negative 4.33. I'm going to do the same, this x-intercept, second trace, number 5. Enter, enter, enter. So I get the intersection word again. I get 1 and 0. So my y-intercept is 1, comma 0. So my second x-intercept is 1. So let's record that data. Y-intercept negative 13, x-intercepts negative 4.33 and 1. And now the vertex. Once I find the vertex, you'll remember that it gives me the minimum value. Because this is an upward, there is no maximum value. Once I know the vertex, it gives me the minimum, but it also gives me the range, right? All right, let's try the vertex now. So that was our only new skill actually for this whole unit. Again, it's found under second trace. Now you do have to know whether you're looking for a max or a min because this is an upward parabola. We're looking for a minimum value. So that's number 3. And you're going to have to answer the questions, but pay attention to the instructions. It's asking you to move the cursor to the left of the vertex. So use your side-to-side arrows, move it to the left. Okay. As long as it's to the left somewhere, just respond that you've done it by pressing enter. Now it's asking you to move the cursor to the right. So press your right arrow and lock it in. You can see your 2 arrows. You locked in the left, the right. Now the calculator is going to take the guess and find the middle spot. And there's your vertex. And it tells you it's a minimum value, right? So the vertex is at negative 1.67. So here's my vertex. Negative 1.67, comma, negative 21.33. Okay, so I'm just going to record that here as well. Negative 1.67, comma, negative 21.33. That gives me the minimum value, right? Your calculator is even telling you the minimum, and the minimum is always the y coordinate because that's the one that is restricted, right? So my minimum value is negative 21.33. And the domain, that also leads me to the domain, the range, y can be anything greater than or equal to negative 21.33. And that's it for that question. Let's move on. I probably won't do every one. I think there's 8 of them. I mean, I could do every one probably. We'll see what time is like, right? Now this is a quadratic. I know it's a quadratic because I see the x and the squared up here. It's given to you in a different form though. But 0.5 bracket x subtract 1 close bracket. I'm going to use the squared sign, right? I'll just put the little exponent 2 in, plus 7. Now let's press the graph. And there we go, a downwards parabola, right? So sure enough, if you were paying attention to that negative, probably knew before you punched everything in that it's downward. The leading coefficient is negative. End behavior of all negative parabolas are quadrant 3 to quadrant 4. Now, I'm going to draw this parabola on my picture. I need 4 points, right? This one has 2 x-intercepts, the vertex, the y-intercept, so let's go. First piece of info is always the easiest. Second trace, x is 0, y is 6.5. Now let's enter into our y2. y2 is 0. Second trace, number 5. Now I want to find this x-intercept, answer the 3 questions. And I get negative 2.74. And now I'm going to find this x-intercept, second trace, number 5 again. But I have to move my cursor over. Right? If you want to move to the right, move the right cursor. Answer the 3 questions. And I get 4.74. All right, let's find the vertex now. Remember how to do that? This will be a maximum value, right? Maximum, because it's the highest point. Maximum means high, highest value. So I go to my second trace and I'm going to choose number 4, the maximum. Same procedure, move to the left. So you got to move your cursor to the left, right? It's actually telling you what to do. Just follow the instructions. Move it to the left. When you have it to the left, press enter to lock it in. Move it to the right. Take a guess. So again, answer 3 questions. Then it gives you, all right, if I have something like this, 0.999 and 9 and 9, that would round to 1. Because if I'm rounding to 2 decimals, all the 9s would round this up to 1. So my vertex is 1,7. Okay, so let's just interpret this. Y-intercept was 6.5. X-intercepts negative 2.74 and 4.74. The vertex is 1,7. There is no minimum value because it's a downward parabola. So the maximum value is 7. The domain is XER, like always. And the range, well, y is anything less than or equal to 7. Negative lead coefficient. End behavior is 3 to 4. Now, this is where I have to use my calculator though, right? Once again, second trace value, put a 0 in for x and I get 17. Okay, so this is 17. Put a y2 in, y2 of 0. Second trace number 5. Let's go after our first x-intercept, answer the 3 questions. And I get negative 1.78. And answer the next. $4.78. And now I'm going to find the vertex. It's a maximum value. So I'm going to move to the left. Move to the right. And the vertex will be 1.50, comma 21.5. I guess we don't need that 0 there, right? Okay, so y-intercept is 17, x-intercept's negative 1.78 and 4.78. Vertex is 1.5 and 21.5. There is no minimum value. Maximum value is the y-coordinate of the vertex. Domain is always XER. Y is anything less than 21.5. So that was almost a repeat of number 3. Let's turn over. Like I say, I'll do as much as I can. And if you get the gist of it, obviously you don't have to keep watching the whole video if you're watching this later. Clear your calculator out. So this one, it looks for sure like I'm getting a negative lead coefficient. It's in proper form, right? X grid X. So I know I can put down and negative. And I know I can also put quadrant 3 to quadrant 4. I guess I can also put XER, right? And I can also say it's going to have a maximum value, no minimum. So there's a lot you know already, right? If you know a little bit about quadratics. All right, let's go to our y equals screen. Sorry. Negative 12x squared plus 192x minus 543. I think these numbers are really big. I don't think I'm going to see anyone when I press or see anything when I press graph. Oh, I see something, right? But I have no clue what's going on. Now, you could play with Windows a little bit. I see this negative 543. That's my y-intercept, right? So I think this graph, that's where it crosses way down below. Let's try like negative 700 even. And I do see something, right? It looks like it's cutting through. So let's try, I'm going to increase my X max, I don't know, to 100. Just kind of playing around. That's way too much. Now, at this point, you might say, you know what? I don't want to keep screwing around like this. I'm going to use that trick that Kim showed me. I'm going to just go zoom 0. But even zoom 0 has its problems, right? So zoom 0 gives me half, but I want more. I need to see lots more over here. So that's my x min. So let's try, actually, let's go try just putting it back to 0 again. This calculator is really, let's go zoom 0 again. It's a little bit better, right? Okay, I definitely don't need anything more up here, but I do need a little more on this side. So let's do a 30. And as long as you see everything you're supposed to, right? You can see there's no exact science. I'm just playing around using my knowledge of the calculator, using my knowledge of Windows. Zoom 0 did give us a definite starting point. When you use zoom 0, you can see how the windows changed your y-min and your y-max, right? So let's see what we got. We got my y-intercept, my 2 x-intercepts, and I think I can see my vertex. You might want a little more on top on the x, on the y-max. So you might want to say, I don't know, like 500 even if you want. It doesn't really help us out that much, does it? But at least it gives you where the vertex is. So let's do second trace value, put a 0 in for x, and I get negative 543. So that's negative 543. Now I'm going to put my y2 statement in. Y2 is 0. And then second trace number 5. All right, so let's see if I can see my vertex here, right? Okay. Answer your 3 questions. So that's going to be 3.67. And now it gets hard. Maybe we do want to add some more onto our y-max. Let's do a y-max of like 1,000. It just gives us a little more room up here because when they start putting the equations up here to answer the 3 questions, it gets a little harder to see what we're looking at. Okay, now I'm looking at my second x-intercept. So here it is. Answer the 3 questions. So I get 12.33. And then I have to find my vertex, right? This is the maximum value. Now I have to move to the left. And then I have to move to the right. And I'm just going to take a guess. And that would round up to 8,225. That's a really weird vertex. The maximum value is 225. Therefore, y is less than or equal to 225. And then I'm just going to kind of duplicate this. So this is a really kind of a wide parabola compared to the ones we've seen. Negative 543. I got this one and this one, right? 3.67, 12.33, and the vertex is 8,225. That was a strange one, right? All right, let's take a look at this one. This was a sneaky one. They tried to sneak something through. Now, if you're ever given a statement with y plus 3 equals 5x plus x squared, your calculator only can graph y equals statements. So this positive 3 has to move to the other side. And your statement becomes y equals 5x plus x squared minus 3. Or if you remember you could enter it in proper order if you wanted to as an x squared, a positive 5x, and a minus 3. That kind of tells you a little bit about what the Lie coefficient is. When we talked about polynomials, we talked about proper order. That's the highest power first, and then the smallest, and then the constant. Make sure you clear your calculator out. because that last one was a very strange question. Okay, y equals x squared plus 5x subtract 3. Let's press graph. This is a nice one, right? Direction of opening up, because I have a positive lead coefficient of +1. It's an invisible one, but it's there. So positive quadratics are always from quadrant 2 to quadrant 1. All right, let's go through the motions. Y-intercept -3. I put a y2 of 0, and then I pick my intersect. Okay, let's find this x-intercept first this time. It doesn't really matter which one. So I get 0.64. I'm going to put it over here. 0.64, 0.64. And now I'm going to find this one. -5.54. And vertex. So it's a minimum value. And we're going to move to the left. It doesn't really matter where you are on the left or the right, as long as you're just to the left and the right somewhere. And my vertex is, and you know you're getting, because it'll say the min or the max, right, depending on the appropriate word. So -2.5, comma, -9.25. If your second digit is a 0, you don't necessarily have to put the 0 in. That was a minimum value. Oops, sorry. Of course it was a minimum value. The minimum value was a -9.5. No maximum value, domain XER. Once you know your min or your max, you know your range. So y is greater than or equal to -9.25. Just one quick last look at the picture. Just going to try and duplicate it here. Kind of do my 4 dots. Connect the dots. And now I'm just going to label with the info I just found. -3. -2.5, comma, -9.25, and then -5.54 and 0.64. Okay, so that was kind of an oddball question. We included that just so you know what to do. If you're not given a clean y equals, you have to move all the other terms over to one side. These last 2 questions were just to also tell you it doesn't matter what side your y equals is on. Let's clear your calculator. It doesn't matter, like this is your y equals statement, right? So it doesn't matter if your y equals is on the left or the right, as long as the y is isolated. Okay, whoops, sorry. Doesn't matter what side your y equals is, as long as the y is isolated. So let's go to our y equals. And our statement is 5x squared, subtract 32x, positive 51. It looks like we're going to get an upward parabola, right? Interesting. I don't see my y-intercept. I know it crosses somewhere there, so I am going to change my window. I don't know, I'm going to go, well, my y-intercept's 51, so I'm going to go 100. There. Okay, so now I can kind of see everything. So let's try y-intercept is 51, just as we knew. Now the x-intercept is interesting. It looks like there might be 1. It's hard to say, but our calculator should tell us. Put a 0 in and then go through the motions again. And I'm going to go down to here. So because I get a y or x-intercept of 3, y of 0, so let's do 3. And let's try to move over again. Let's try this second trace number 5. Let's move over here a little bit. And I do get another one, right? See what I did there? I got a 3.4, so there were 2 x-intercepts. I'll just show you once again, second trace number 5. Right, so I did get another 2 intersection points. All right, that means there's a vertex in the middle and it's a minimum value. Okay, so I'm just gonna kind of move kind of to the left that I can see. And then I'm gonna move to the right. And my vertex is 3.2.2. Zero 0.2. And it makes sense, right? The vertex is right smack in between my x and my x-intercepts. The vertex always has to be smack in the middle of your x-intercepts. So this graph looked like it actually looked like it, or sorry, that's a negative 0.2. So it actually goes like this. Just barely under, right? You have to be really careful there. So this one was 51. I've got this, this, and this. So I've got 3.4, and 3.2 comma negative 0.2. Minimum value of negative 0.2, no max. And this stuff at the beginning, I guess we could have done at the beginning. Positive and up. Okay, I may as well finish the last one, right? And then we've done the whole assignment, so you can go back and look at it. It's so repetitive, right? But that's why we include lots of questions to practice so that it becomes so repetitive that you can almost do this in your sleep and you develop a muscle memory on how to do these questions. So you have no problems in finding x and y intercepts of more complicated functions next year in the grade 12 course. All right, so y equals statement. I've got x squared plus 17x, subtract 23. Let's see what this graph looks like. Well, I know my y-intercept is negative 23, right? I really don't know what's going on. I'm going to play around a little bit. Or let's try our trick. Let's go zoom 0. Doesn't really help us out that much, does it? I need to see way more over on this side. So I am going to say like negative 50. Let's see what that gives us. That was just kind of a guess, but that's an okay thing, right? I have my 2 x-intercepts, my y-intercept, and my vertex. I mean, you don't need all this, so you might want to reduce that negative 50 to negative 20. Let's see if that looks a little better. That might be a little nicer for you. All right, let's go through the motions. So I have a negative 23. So this is a really weird, strange one in a way, right? It kind of goes like this. Maybe not even that low, but so this is negative 23. And then let's find our x-intercepts. Put a y2 of 0. And let's take a look at the graph. Now, you can change your graph up to make it suit what looks nice to you, right? Just by playing with windows. If you say, hey, I want to see more down here because I don't like the way that looks, just increase your y min, right, to negative, I don't know, like negative 250. This one's positive 250 about. Let's try it, see what a negative 250 is. Like, I don't know if that's better or worse for you. Maybe you don't like, right? Maybe you want to include more on your x's. I'm just going to play around a little bit. So if I do a negative 50x and a positive 50x, it's the same graph, right? It's the same grid, but that might be more appealing to you, right? Things get a little squishy over here, though, so I'm not sure if you like that or not, but let's just keep it there. So I have my y2 statement in, and now I'm going to pick my x-intercepts. Let's go for this one first. So I get 1.26, I guess, right? Positive 1.26. And let's try this one. and it's a negative 18.26. So now I just have to find my vertex. So that's the minimum value, right? Whoops. Number 3. Now I'm going to move to the left, move to the right, take a guess. My vertex is negative 8.5, comma, negative 95.25. Again, kind of a strange one, right? The numbers don't really go together. It looks really weird, but negative 18.26 and 1.26. Vertex is negative 8.5, comma, negative 95.25. Minimum value is negative 95.25. No maximum value. As always, the domain can be any real number, and the range is y can be anything greater than equal to negative 95.25. And there you go. That was all the questions done. If you didn't have time to work on them on your own, take a couple minutes this weekend if you can, or later on today or at some point, and just try and work through a few of these and make sure you know how to find x and y intercepts and the vertex. That's a super important point. All right, let me know through email or through the live chat here if you have any questions or how you're doing in the course, because I'm not really hearing it with any regularity how everyone's doing. And then Monday, we're going to start looking at applications. So have a nice weekend, and I'll talk to you next week.